Welcome to September's Leetcode challenge. Today's problem is largest number. Given a list of non-negative integers, arrange them such that they form the largest number. The result may be very large, so you need to return a string instead of an integer. Now this is a hard problem. It's much harder than it looks. But I'll go through the steps that I went through to try to understand this. And you might see me struggle as I try to go through it. Now the very first approach I thought was, well, this is a recursive solution, isn't it? All we need to do is find every single permutation that we can possibly come up with, build up our string, convert into an integer, and just get the maximum out of all of them, right? So let's go with that approach first and see how that turns out. Let's start with initializing a self variable for max, and we'll start with 0. Now we're going to write our recursive function, and what we'll pass in is our string that we're building up. So this will be called our build, and whatever numbers we have left so far that we need to still add to the string. So we'll call this left so far. Okay, so as soon as we say, all right, if not left so far, there's no more numbers to add, we are going to try to update our max variable. So we'll say, hey, get the max between self.max and whatever our build is. And this will be a string, so we need to convert it to an integer. And what we'll do is reconvert that to a string later. All right, so now we want to go through our recursion. So we'll say for I in range of everything that's left so far. So we say length of left so far. We will call our recursive function by adding to our build a string of left so far I and pass in whatever's left so far. So we could either pop off and do backtracking and add it back on, or I'll just pass in a brand new string for simplicity stakes. We'll say so far all the way up to I plus left so far from I plus 1 all the way to the end. And this will guarantee that the one that we just added is no longer on there. So once that's finished, we will first call our recursive function, and we'll pass in nums as our left so far. Then we just return our self.max, right? And remember to convert this back into a string. So let's see if this works. And it looks like it's working. And I would submit this. Well, I'll go ahead and submit it. And you'll see that this actually doesn't work. It's going to get a time limit exception. And if you think about that, you're right. Like, of course this won't work. This is an exponential solution. This is very, very expensive. How would this ever work? So this recursive approach is never going to work for our problem. Even with like a length of this, it's only like 10 numbers. It's not able to do it. So back to the drawing board. How could we solve this without recursion? Well, let's look at our example and think about what do we need in order to get this to be the largest number. Now, first it kind of looks like, oh, well, don't we need to just get the largest like digit number? Can we sort this lexicologically and see if that works? Like all we need to do is get 9 in front, then 5, then between all these threes, like whichever's larger, get 3, 4, and then maybe 3, 3, 0. So what if we do that? Like, why don't we just sort it lexicologically? So to do that, we can just use the first convert it to a string, pass all these numbers, and then why don't we just sort it? And we can just make it reverse equals true. But this isn't going to work, and I'll show you why. Let's print it out and just take a look at why this wouldn't work here. Because at first I got all excited. It seems like an easy solution. But the reason this doesn't work is we see our answer is 9534330. We can see here that 30 comes first when we sort it lexicologically. And this is a big problem because how can we figure out, no, we need 3 to come before 30. But obviously, lexicologically, 30 is greater than 3. So do we just have like pointers to compare the index numbers? Like, what do we do here? Like, say that we have these two numbers. We see a problem where it's like, we want 3 to come before 30, but we want, like, say we have 33 and 334. Well, here we want 334 to come before 33, or I should say 334 to come before 33. So the logic here becomes really icky. It's like it doesn't really work very easily. So let's back up again and think about, all right, just if we had these two numbers, how do we compare them? Like, how do we know which one to come first? Well, forget about looking at the digits, looking at the integers. Why don't we just add them? Like, just add these together and compare. Like, if we said, all right, 3 plus 3 like this, is this larger or is this larger? And if we find that, well, this is larger, then we know that this one should come first. Same thing here. It's like we say 3, 3, 3, 3, 4, or 3, 3, 4, 3, 3. Which one's larger? Well, this one's larger. So we know that this should come before as well. So that gives us a big hint there. All we need to do actually is forget about any weird algorithmic thing. Just add them and just see which one's bigger. And that's all we need to do. So let's write a function to do that. We'll say, all right, largest, we'll have two numbers. And at this point, I'm going to assume that these are strings. And we'll say, all right, if a plus b is greater than b plus a, then we want to say, actually, kind of like if we were sorting this in reverse order, we want the smallest one to go to the end, right? So if a plus b is greater, then we want to just keep it. Just say, yeah, a is greater, so keep it. Otherwise, if it's the opposite is true, if a plus b is less than b plus a, then we want to swap. We want to say, hey, take a and take it, like swap this, make this go to the end, because we want b to come in front of a. Otherwise, they're equal, so I guess in that case, we can just say, return 0. All right, so now we have like a function to do some sort of sorting here. How can we sort it? Well, let's just do something simple. Let's start with like a bubble sort and say, all right, for x in range of, let's see, length of nums, and we're going to go in reverse. We're going to say -1, -1, -1. And this bubble sort is how we get, well, usually we get the largest number to go to the end, but here we'll get the smallest number to go to the end. So for y in range of x, right, what do we want to do? We say, all right, look, if nums, well, pass in our if largest nums y, nums y plus 1, and let me think, okay, I think that should work. If this is the case, if we find that, yeah, this y plus 1 is greater than y, then we should swap it, right? We'll say y plus 1, and we'll just swap the two. We'll say nums y plus 1, nums y. Now we should have a sorted nums thing. And I just realized I need to pass in a string for this. And I'm sure there's more efficient ways to do this, but for now, let's see like if this worked here. Like if I got this sorted in the way that I wanted, and it looks like 9534330. It looks like it did. So let's go ahead and what we'll do is convert this into a string. We'll use the map method, string, and we will just string join, right? We'll say string join all these strings and return that. And that should give us the right answer. Let's go and submit that. Oh, okay, so there's an edge case with zeros. So to avoid that, I guess we just convert it into an integer. And then we'll reconvert it to a string. So that's, I don't know if that's cheating, but let's see if that works. And there we go, accepted. Barely. This is barely accepted. It's a n-squared solution. Can we do better than this? And we could use a better sorting method like quick sort or merge sort, but I just didn't feel like writing that whole algorithm. One way you could do it is to pass in this function as a lambda key, but the problem is we have two numbers to pass in, right? So to kind of take care of that, there is a function called compare to key. And we could pass this in to get this to work. Let me think. What we do is say, all right, pass in a lambda ab, and we will call our largest function ab like this. And one thing you do need to do actually is to subtract this -1 if we want this to get, it's just the way the key works here. So this will be our key. And what will we do? Okay, let's get this guy right here. All right, and we will sort this using our key. At this point, this should be a list of strings all joined. So again, I just need to do our string join method. And don't forget to convert it to an integer and back to a string. So this is a one-liner, almost a one-liner. But it's very icky, you can see. All right, so this would be faster. This would be n log n, I believe. And it is faster, it's much faster. Now we could have written the actual sorting method out, but I just didn't feel like doing that. This does work. It's a hard problem. This was a hard one. So I hope this helps. Like, you know, I had trouble with this. I wonder if other people had trouble with it, but there we go. So thanks for watching my channel. And remember, do not trust me. I know nothing.